Hello and welcome to VLSI for All. I am your host Shrutishmita Bose with yet another insightful expert talk on semiconductor industries and career. Today we have an incredible guest with us, Dr. Alex James. He is a renowned scientist and innovator and educator in the space of AI hardware, neuromorphic VLSI, and analog electronics. He is currently working as the Dean in Digital University Kerala and the Director in Indian Institute of Information Technology and Management Kerala. With global recognition as one of the topmost cited scientists in electrical and electronics engineering for 3 consecutive years is nothing short of extraordinary. So, without any further delay, let's start the conversation. A very welcome you, sir. So, could you start by sharing a brief overview of your journey so far and all the key milestones that have shaped your career?
Okay, so if I really pinpoint what is that career aspects, which were the milestones, and I would say it's not the degrees or the other achievements. I think it's those little curiosity things that come on the way, and I think two things that I can visualize is one is asking this very question of what is an Ohm's law, looking at a simple equation like V equal to IR, and then asking this question as of, okay, if there is only one free electron,
Yeah.
whether, V equal to IR hold. Now, when you further dig into it, then you realize that like many of the mechanisms that you are familiar with in a single free electron makes the whole equation seem very different. It's no longer a constant conductance that you're talking about. You're talking about maybe a voltage or current dependent Ohm's law, which is very different from a V equal to IR concept that one would get introduced. Another aspect I could relate is while going through the various part of the studies, there was one thing that keeps on bothering me: how the brain works, and the whole idea of how the intelligence itself is shaped. So later on, when I pursued various degrees or electrical engineering and other things, you tend to realize that if you want to build a silicon brain, then first thing is you need to understand the brain, and then you need to also see the merger between the electrical engineering principles and the neuroscience principles that are there, and then you try to build something. So today, AI hardware is a huge field. But back when I started, not many people were talking about hardware in AI. Most people would see it as an algorithm, when people think about machine learning or neural network ethics, that it always resonated as an algorithm.
Right.
Whereas, and I remember when you go into a particular conference and talk about it, again, people ask why. Right? So all those things I think is because of those two questions, that actually resonated throughout the career.
Yeah. Okay. So my next question will be that you hold significant roles as dean and as well as the director, right? So could you share some experiences or the roles and responsibilities in these positions?
So both of these are very much administrative role. So fundamentally, I'm not a manager, so I'm still like a scientist and an engineer. So if you put a engineer or a scientist into managing something, that's a very different proposition, right? So you'd always want to do something. So you want to build something, uh, which means we are very practical people, right? So we want things to be done. We want to ensure that it happens. So when I took over many of these administrative roles, uh, one simple thing is I asked this question how fast you can do it, how efficiently can you do,
Right.
and whatever it takes for doing that is the question that you're addressing. So that's one side of the management. Other thing is one thing you realize working in any research project or a larger project are that they are interdisciplinary in nature. And when there is interdisciplinary, an important thing that comes with working with people.
Yes.
So you don't have a choice to decide who you work with, but you need to find a way that the skills are complementary and the ideas become complementary, and everyone gets to share their views and express their ideas and contribute. Okay. So paying attention to those little details becomes very, very critical. Some people are good at speaking, some people are very bad at it, but both may be very good contributors. So how do you ensure that your team would contribute becomes an important aspect? And in the roles, one part is I look at developing entrepreneurship related activities. So there are a couple of incubators. One is Make a Village, which is having around 80 hardware startups. So how do you support these startups, and how do you put these mechanisms in place so that these startups get a fair chance? Then other side of role that I have on with is with students, right? And students come with all sort of different issues, different challenges and things like this. How do you make the teaching and learning more efficient? So one of the thing I was very passionate about was experiential learning. So this question of teaching and learning, can we shift the role of teachers more towards learning rather than teaching? Can every class contribute something meaningful towards learning? Right? So today's world, and if you're doing an engineering course, why would you want to listen to a lecture, right? When you can find all the things on YouTube. So and people are not even reading books, right? So these days, everyone is looking at different sort of other materials. So what it means is that, fundamentally, the way you approach teaching and learning has to be different. So what we did, we removed classrooms.
Okay. Nice.
So basically, labs are the classrooms. So if someone is explaining OPA, basically take an OPA
Okay.
and show it. If I have to teach what is a resistor, the best and easy way to do that is ask people to take a hammer, break the resistor, and see what is inside. Yes. And it just opens up a completely different world in front of you. Because many times I ask this question, have you seen that resistors? We won't say I've seen it in the lab, you have that color coded thing as things like this. But have you really cut open it? No one has. And once you start opening it, you see, oh, this is not how I imagined. So it's something very, very different.
Yes.
So that opens up the whole concept of taking the ideas from the textbook to the lab and really understanding the concepts. And what I have observed in the last few years is that primarily we have master programs, PhD programs. We don't have undergrad. So most of the students who come from various colleges, they're educated in a particular way, right? They go through the normal written exams, they memorize the stuff and all these things. And then first day you are told, cut open the resistor, the world looks very different. And and then you have to reorient the entire thinking. So they struggle in the first semester.
Yes.
But then once you get used to the questioning part of it, you get used to the creative part of it, then you soon realize that, this is more meaningful and I want to explore even more, right? So then the books are not really needed. You're rather looking at user manuals. You're looking at requirement specs. So it's no longer okay, mug up stuff from the book. And textbooks can be used still as a way to refer at things, but primarily you're trying to build something. And that's what educators are supposed to do. So a fundamental change in thinking, that's what you're looking at. So these are some of the things I think
Yeah.
that we're trying like this.
Okay. So, as you told me that, like the graduate students who are coming for the masters, so they are like facing the challenges because they are trained in a certain way in other colleges. So, is there any conscious choice to not have the undergraduate and have only the masters and PhD?
Um, Not really. So the idea is that we'll have it in the due course.
Okay.
So an undergrad uh, program requires much deeper preparation,
Okay.
right? So if you are looking at like a 4 year or a 5 year or 6 year program, uh, you can have an integrated masters.
Yes.
So yeah. So if you are thinking about in that sense, then the biggest challenge is how do you redefine the way people are educated? So currently there are many regulations like across the universities and UGC to others. At a high level, those regulations make sense, but from an implementation point of view, a lot of work needs to go in the current situation. So imagine you want to include something like a research integrated learning. So first year, how many universities in the country would allow an integrated, research integrated learning? This is hard because there is a lot of views for and against it. Some faculty would say, okay, you need to have it, and many others would say it's too early. So there is a lot of debate on it. Same thing with like experiential learning. Like is it feasible to do it at scale? So if you have 300 students in a classroom, can you actually implement like learning at that scale? So it requires a lot of thought and preparation, and we don't want to rush into it in the day one. And that okay, you need to try it, but like start something small and then build it up, rather than just falsely advertising it and say that it's amazing. No, it's not. There are a lot of learning challenges and all those things in there.
Okay, okay. Nice. So now we'll come to some like academic parts of you. So your academic journey began with the PhD degree from Griffith University, Australia, right? So what exactly motivated you to do research in abroad, and what was the admission process like?
Most of the universities that I applied at that time, I had offers from US, from UK, and key places. This when I was looking at like the possibilities of doing a PhD. In PhD, what I realized is that many people struggle, take a lot of time to complete it because they can't figure out the problem, what they are addressing. So clarity in identifying that problem with the supervisor becomes very important. So before I started that journey for PhD, I spent almost a year trying to figure out what is the problem that I'll work. So I was talking with several prospective supervisors, um, and going through that process to see, okay, is this something that I would want to work with? And uh, is it a supervisor that I feel comfortable working with? So I was not particularly looking at like university rankings or anything of this nature. Was really looking at like the facilities, the work itself, the supervisor, the environment, and these kind of things. And that really helped. And so when I went there, like I knew exactly what I was wanting to do, and it was straight away getting onto the job. From day one itself, like was actually doing research. So there was nothing like you'll explore the topic and figure out and all. So that just practically not there. Like in day one itself, like I started working and finished it uh, very early as well. So
Okay, okay. Yeah, so actually many students are planning and wanting to do.
people who you work with and the facilities that you have to ensure that you do a high quality work that is of international study,
Yes.
right? So you can go to the best university in the world and do a very crappy work.
Yeah.
You can you go to a very bad group and you end up suffering. You get a degree. So what's the point of it? In today's world, people want contributions, real contributions that actually make sense, right? Employees want people who actually do the work, not poster boys, right? So we want people who actually do the things. So as long as you are able to make those contributions, you see who are the people who are working there, like, the graduates, where are they going? What is the kind of publications they do? Um, the quality of the work, you basically just need to read it, right? Read some of the works that people have done and make a judgment on your own, rather than 10 people will say 10 different things. Uh, Not that, but you need to pursue your own those decisions and 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 grow over it and establish yourself as a serious artist.
Yeah. Okay. So as you know, like there are some fields where which is like saturated. So if someone does PhD there, so it will take a long time to complete the PhD. So what will you suggest? Like should they prefer doing like whatever they want the domain, or like to research first of all, like which domain will take a lesser time, and then choose the domain, like where should they research?
Yeah, that's an interesting question. So see, uh, it all depends what kind of PhD do you want to do,
Okay.
right?
Hmm.
So if you're looking at I want to do something incremental, take maybe just like adding a little bit on top of like what others have done.
Yeah.
Obviously, you need to look at those areas which are very popular. Maybe ensure that you get a job. Right. But if you are looking at trying to attempt something very difficult, it doesn't matter what you do, right? So the chance of failure is high,
Yeah.
but the chance of reward is also very high. Many a times, people, good PhDs always pursue difficult problems, and it comes out of a passion to do things rather than what the trends are. Many a times, those are the people who set the trend, right? So it's basically you need to believe in what you do. You need to pursue the passion that you have, and don't worry about AI or whether it's uh, blockchain or whatever is popular, quantum, whatever, because that will follow later. People who worked in quantum, who had done a lot of contributions, when they started doing it, hardly anyone was there, right? Now you look back and most of them would have, oh, I read his work, read that work. But if that person did not pursue that journey, no, all these other things would not have happened. So pursuing that original work, taking that risk of really finding something that is meaningful, that you feel like passionate about,
Mm.
and going in depth, high quality, uh, is I think what makes a difference.
Okay, so also they should not get frustrated also due to
No,
the
one says no. See, a PhD, how much years? Like some people finish early, some people finish like a bit late. But even if you spend like 5 6 years, in the longer run, it doesn't matter, right? So 20 years, 30 years, 40 years of your career, when you pursue, you spend like 5 years training yourself, or 3 years training yourself. That's not a. So,
okay. So my next question will be that you have contributed extensively in the fields like memory state system and then neuromorphic VLSI and AI hardware, right? So how do you see that these innovations are actually impacting the real world applications?
yeah. So if you look at AI hardware, it has grown quite a bit in terms of where you can use it. So wherever you hear the word like AI today, whether it's deep learning, NLP application, machine learning, or the LLMs, everywhere you would see energy efficiency is something that is becoming more and more important. So today, energy efficient systems uh, becomes even more critical because we are taking in a large amount of data, and we are collecting a lot of data from sensors and other things, and all of these are contributing to how much processing is needed. So what has been successful so far was to use digital systems, uh, because the scale of the data is so large. Even if you push the limits of how much you can store and process, the energy efficiency is still a big problem because overall cumulative energy that is needed is still very high. So how do we manage that? And then you work backwards and then you start asking this question. Oh well, if we want to do an intelligent processing or make such decisions, how does brain does it? Brain hardly does it with a 20 watts. While the best of the systems that we have today would need megawatts or more to do the same task.
Yeah.
So fundamentally, there is something that we are not doing right. So that's where, all the other technologies are coming into picture to actually see, okay, is there any other way to do the compute? Uh, if you look at the brain and try to understand, can we do more efficient way of processing, energy efficient, area efficient way of actually processing the data? So that's where things like neuromorphic comes into picture, like spiking networks come into picture, all sort of neural networks what we have today. How do we implement it in a way that is energy efficient as like a brain
Yeah.
would have come into picture? So that entire field is trying to see that. And another aspect of seeing it is also see from the devices side as well. Do we need the traditional CMOS, traditional FinFETs and things like this, or should we think about any other kind of devices like memory devices and others? And why memory devices are interesting is because you can have like a spike response like implemented in a very small area, and you can also do an analog compute as well with it. So that way you have a system where it kind of does in a way like what brain would typically do. It does like a digital and analog. They basically try to combine those. It's a naturally optimized system that humans have. Can we kind of mimic that structures and functions in a way that you could combine those functionalities both at a structural level as well as at the device level? Can we try to do that? So that's why it becomes very, very relevant in today's context.
Okay. Hmm. Okay, so your team at IIIT MK has developed the analog circuits for ligands, right? So, could you share some insights about this innovation and also the highlight the practical applications of this in real world?
Yeah. So uh, GAN is one of the things that we tried. We looked at a lot of different um, neural networks, and the heart of it is simply like a MAC operation, right? So if you have a weighted summation, that's what you're trying to do. Um, and how do you do that? So a common way in analog to do it is having a crossbar kind of structure. See, so if you have a crossbar kind of structures, then the weighted summation uh, in a crossbar in a column would represent like the weighted summation of LU.
Yeah.
So if you have large arrays possible to be built, then you have a layer of neural network implemented in a comparatively really low area or on chip area. Now, whether power gets reduced, that's a different question, because then you need to see how to take that data, like if it's analog compute. If you're going to do processing further in analog, then you need to figure out all the peripheral circuits which are needed, the data transfer, how it happens, and all those things. So that's where optimization may be needed. So we looked at those kind of structures and built all sort of neural network, cellular neural networks, convolution neural networks, analog GANs, we to generate like data or images and other things. Then we are looking at LSTM. We had a complete implementation of analog LSTM. There were pixel CNN circuits. So there is a whole range of circuits that you can build. What are the applications? Essentially, whatever you can do with neural networks, right? But then when you are thinking about hardware, you are also looking at like energy efficient processing and whether you can use it in a effective way. And you can see that straight away you can have chips integrated on the edge applications. So any kind of edge-based processing is something that you would think of. Recently, we tried something like integrating with antenna. So for astronauts, like when they are in space, like you have hand gestures as a way to communicate. So we had to build a wearable, by the movement of your hand, like that gestures could be then transmitted in without like them having to speak. So what we did was like that recognition was in a analog memory network, whereas like the radiation pattern changes were being detected as the signals that goes. So that's one example. It's quite, yeah, one interesting example. Uh, and designing like or predicting like antennas, like predicting how to design a neural network itself, like parameters as neural network. You can accelerate that. I think we did the first work on analog backpropagation implemented in a chip.
Okay.
Right. So that was again like a question of how do we do on chip. So when we started doing this, like almost everyone kind of told like you cannot do it. It's like analog, all thousand problems. But increasingly we believe that like that is a way to go about. It may not be purely all analog, but you basically have a mixed signal system. Um, Obviously, designing such systems are a bit more cumbersome than having a digital only system. But at the end of the day, brain is not a simple system. Brain is a complex system, and there was a natural evolution over billions of years which helped to do it. We need to be a bit more smarter than natural evolution, so we need to find like a engineered way to do it, and that requires like a lot of research, effort, and things like this. But it's in that direction.
Yeah, okay. So coming to that only, like, why do you think that people are more interested to do in like digital compared to analog? Like, what can be the reason that?
Yeah, I think like humans are generally lazy, right? So if you think about it, why is Python so popular than C programming?
Yeah.
So well, it's not that Python is better than C. C is much more efficient. Or even I can say even assembly may be much more efficient, right? But no one does the coding in assembly or like C. I mean, people still do it. Like one part of the people who are working in hardware, they still do it. But if you look at the application development to many of these things, everything is done in Python because the turnaround time that is needed, like uh, is very fast.
Yeah.
And when people move away from the idea of actually solving a problem and only thinking about making money, then time becomes very important, right? So when time becomes quite important, then you need to have methodologies and ways in which you can automate and speed up the process. I mean, same thing that has happened in industrial revolution, like you're just scaling it up to. So while the solution of having like analog or mixed signal systems may be the right approach, it's still hard to automate. And because it's hard to automate, that's why it's less popular.
Yeah.
Right?
Mm.
If the analog was as simple as writing few lines of code, just how you would do it in digital, I think analog will be popular. Uh, but then we need to understand, like why you need to do it, right? Because you're trying to solve something very difficult, and that would take you to take that extra effort for you to,
Yes.
and you can see it in positive or negative. We are able to do it, like you're definitely moving ahead in a different way. Uh, this will, of course, like the plenty of jobs and things like this there. So re- relatively easier and easy to get a job as well, right? So that all adds to that.
Yes, yes. Okay. Okay. So could you share some insights about Vilokana, the AI semantic search engine that has been developed under your leadership?
Yeah, that was something we did during COVID time. Like, in the COVID time, like one of the thing was, I mean, there was no ChatGPT, right? So there was no ChatGPT or anything, or these home document analysis was still like a thing. So at that time, like we thought, there are a lot of these literature coming out on COVID and other things. There was no way to figure out what is right and what is wrong. So then we had a text summarization tool which would scrap all the papers, and from there, like, figure out what is the right one, what is the wrong one, things like this. So this was before ChatGPT and others.
Okay.
So we had this search engine we created, which could do that. And obviously, like after that period was over, then ChatGPT and other things came in, so there was no need for it.
Yeah.
But during that time, we had a good use of it, and
Okay.
we could actually many people use that
Yeah.
to figure out the
Okay. Okay.
data.
Okay. So, as an educator and mentor, working closely with the students, how it has actually changed your approach towards the research and the this space, like when you're all actually working closely with the students. Yeah.
No, see, students are still like same staff few years back, right? So now, if you think about students as learners, you can also think staff also as learners, right? So if someone working in a company wants to build a product, right, you would still need to go through a learning, which was not something that you got in the university. You're still trying to figure out, there is no standard textbooks available for it. You have to still search, you still need to experiment, you still need to try. So if you see it as a learning process, then it doesn't matter whether it's a student or whether it's a staff in a company.
Yeah.
So the approach of uh, learning becomes more critical than uh, you know classifying them as a student or a staff.
Okay.
So many times when someone comes in, like my question to them is on the learning part rather than classifying it them as like, okay, whether they can do it or they can't because their experience of the not experience and things like this. So I work with like people who are first year of engineering. 2 years down the line, we wrote like research papers,
Yeah.
right? And when you do that, right, it tells you that uh, doesn't matter whether you have 10 years or 20 years or 30 years of experience. What matters is, are you still curious to learn? Are you still having that drive and motivation to push those boundaries of learning?
Okay.
The- and younger people are much more energetic, right? So if you take a proportion, in that sense, you can say students are generally more energetic, and they lose the interest later on, but at least the initial stages keep that right direction and right place, and the environment for them to grow, then becomes meaningful. If you see that learning process as assessment, then the interest dies out in a year time. So if people are chasing grades, if people are only chasing that artificial things, then what happens is like in a year and a half, you would see like the entire purpose of learning and education just gets into a completely different direction. And then most of the people who work with those students were not even motivated
Yeah.
to engage. So I think it's very important that stress is put on learning, and that's what I do.
Yeah.
And that's what makes it like.
So, you have been recognized as one of the topmost cited scientists in electrical and electronics engineering in globally, right? So, how do like this honor is actually implemented or influenced you in your research approach?
To be frank, it hasn't. It, so see, those are someone cites your work, or they found it interesting. Is definitely something that you would see that people are finding it meaningful in one way or the other. So that is one side of the story, but then that doesn't usually influence the work that you do, because many a times you are doing the work because you want to pursue something meaningful and useful. So, uh, and whether that drives it, like, that pushes you to do more in it. I don't think it's really like, the interest, like, you have something more to be done that forces you to do more in it rather than, because like someone else said it that,
Yeah.
so uh, I think that's the answer to it. It really has an influence much.
Okay. Okay. So, you have been awarded as the best associate editor in IEEE TCS one, right? So, and also you have contributed in many prestigious journals. So, how do you actually manage this, like the publication and the research and also the leadership work? So, how do you manage this simultaneously?
So time management is always a problem, right? So whether in whichever stage of your career, so whether you are starting as a student, like we have the same problem, like, when you ask them, oh, I have so many assignments to do, I don't have time for this, I have time for this. So it's about setting priorities to a great extent.
Hmm.
I still have a lot of time. So it's not that, uh, when you do a lot many things, uh, you don't have time for other things. That's not entirely true. It's simply that, we set priorities many times wrongly, and that ends up like eating a lot of time, right? So things, as you move further up in career, one thing that you realize more is when you are attempting any kind of serious problem or task, it's usually a teamwork. Right? If you start doing everything by yourself, then obviously, like, you end up not getting time for anything, and even the quality of the work also drops down. So it's really identifying the right kind of team who you can work with.
Yeah.
You, you need to mentor people. You need to create a lot of replicas, right? So how you need to share your experience and to get people in the team who also learn because of that, and ensure that the overall success of the project is more important than, like, individuals. Which, like, individuals are of course important, but then everyone needs to realize that success of the project becomes more important. Yeah. So in that sense, it can be practically managed in many ways. Other thing is to really see what is important to you, right? So if you see that something is really, like, important, you might want to spend more time on that compared to some of the other tasks that you. So prioritizing and giving an importance to
Yeah.
the effort that you do, that becomes critical. And that works. And so far, um, I think whatever, like, roles I've taken, I only take if I can do it. If if I can't, I just say no. I can't. Right. So simply because it can be, that I see, okay, if I put like this much amount, it's good enough. Then for this particular task, and for some of the others, you need to spend more time. So you just prioritize it and get it done.
Hmm. Okay. So, as a senior member of IEEE Kerala, so how do you see that this organization is actually contributing to the growth of the state and the technology space?
Yeah, this has been very interesting. Like, association with IEEE, like in Kerala. Like when I start off there, like pretty much it was dormant. There was no activity in circuits related area. And there were very few who were doing some work, like AVC DAC had like a processor team uh, and some power electronics related work and things like this. Like pretty handful of people. But when you look across, many engineering colleges and other, they study like electronics. They teach electronics, but no one has done any tape outs or gone to that level. So this is something very surprising to me when I started off. So IEEE was a good way to get connect with people. So bring the student community and the faculty community and the industry on a single platform. So we had like a Civilization System Society chapter, and I started with 5 people, uh, including some of the students. Like they registered and got it started. Now we have 500 plus, right? So the journey from 5 to 500 plus, and last 2 years globally, you got recognized as the best chapter uh, in the world.
Okay.
So that transition happened in a place where there was absolutely no uh, interest. So which means like there's something that's doable, right? And it's something uh, to be globally competitive. You need to see what it takes. You need to engage and give that time. So we had several events, activities, which were looking at how do you promote that activity, including like say full tape out. Right? So starting from the design, the way. We also did an international program now, like this year, where 500 people enrolled from different parts of the world, and collectively they are putting the design into a simple chip, and we are doing it about like in April. So from that to that is possible, and it is creating a interest among students going beyond like computer science. Like today, computer science is very popular, so people go into electronics. At least what I've heard from people is that like that's the second choice. Or, they don't get into computer science and then they go into electronics. But that's not that need not be the case. Once people know that it is a potentially good field, and there are examples for them to see, the interesting uh, aspects will pull the students into it. Right? Good people would want to come and work. And when you see high quality work, when you see like outcomes, then naturally like more and more people who want to join. And that's exactly what was happening. And many people were coming together because they were seeing a value addition. So it does like very meaningful things.
Okay. Okay. So for the like young students who are aspiring to do some impact in this space, so what step by step guidance that you'll provide them?
No, I think fundamentally everyone is curious, talented, and good at doing things. It's just that we create a lot of averages, right?
Ye-
So the people learn differently. And there is a some cartoon which showed like there is a bird, there is an elephant, there is a crocodile, all in a picture, and the teacher says like you fly. Asking elephant to fly doesn't make sense, right? So this is exactly the problem. So we have created an education system which doesn't recognize like the multiple base of learning, multiple targets that are there in learning. You may be learning VLSI, but you don't have to assess everyone in the same way because people learn differently. They some people may be very good at theory, they understand maths better. Some people may be more good in creative design kind of things. Can we have a system which would promote all these? That requires that might shift change in thinking, overall thinking. So once you see in that particular way, everything for that matter like looks different. So if you ask like what are the steps involved, I think that's where it starts, right? You need to focus on learning and what is the best way for you to learn. So it's very specialized and it's very individualized. So I can't say that okay, someone who is good, who can read and understand, maybe a good visual thinker may not be. So if someone is good visual thinker, then you need to see things. So maybe seeing a layout makes a lot of difference. Yeah. To understand it compared to someone else, like who may be good in maybe writing a spice code. So one needs to really see what they are good at, and then build on top of it, right? So, you know that, okay, if you are a visual thinker, you need to visualize everything. And then you approach. That would be your first step, I think, to identify what kind of learner you are. The second part is to actually have goals very early on. Okay. Not that I'll try 100 different things and then I'll figure out what is the best. There is nothing like best. There is always a pursuit of um, perfectionism that is easier to achieve than you're trying to say, okay, this or that is good, right? Our brain fundamentally cannot think beyond two. So you give two choices, it's easy. Give five choices, it's very hard. So the indecisiveness increases with more number of choice. So it's better to have limiting the choice between two and use the principle of exclusion rather than inclusion, right? So you have one versus many. That's how exactly how the brain works, one versus many for classification, rather like multi-class classifications. So use that fundamental logic in trying to see what would be the long-term goal that you want to set. Then the journey becomes easy. You may be wrong, uh, but so what? You just take another journey, right? So, but then you would also have gained a lot of things by pursuing that journey, which would have help you gain a lot of skills, which are very invaluable, which you would have not gotten otherwise, right? So when you pursue quality, when you pursue uh, the path of that rigor that one needs to go in, you also gain other things like discipline. You gain the idea of persistence, to how to be courageous, take risk, and how to overcome those. There are a lot of life skills that you gain when you pursue that. But if you are uncertain and you always say that I have 100 different options, I'm not sure which one, then you are in trouble because you would be still doing that 10 years later on, same thing. There's another 20 years again, same thing. You're just wandering around. Instead, make a choice, pursue that, try it to the depth, and then make another choice. Right? That makes it much more meaningful and easy as far as a academic journey or career journey is concerned.
Okay, so you have summarized it the best way possible. Okay. So now, sir, I'll ask you some fun questions. First is, do you have any favorite food?
And I mean, I try everything. So yeah, so I don't have a specific thing. So I used to travel quite a bit. So then I go to almost every continent I'd be. So I tried almost. It just gives you a different flavor and different. Uh, keeping an open mind to explore things always helps.
Okay, okay. So I was going to ask you that only, like, if you have any favorite holiday destination.
Every place is interesting for me. Wherever I've been, I found something interesting. So it's never been. So I wanted to go some really interesting places, but they won't. Like North Korea, but because it's just interesting. So or places which you don't typically think about going. Those places really something you'd want to go and see, and you just hear it from the movies or something, but seeing in person it's different.
Yeah.
So I always like to do that.
Okay. Okay. So any place in Kerala that is probably lesser known or not that commercialized that you can suggest?
In Kerala,
Yeah, Kerala.
there are many places. So see, usually when you look at most of the tourist destinations, they are crowded, and
Yes.
they're catering to a particular audience, right? So you're going there you have this activity you go through. But for me, when I travel, I usually look at the nuances. I just try to understand the culture. I try to see what people are like, what is the kind of food habits? Like, I rather than going to some fancy place, I go to some place where you get some to try something different. So and that you can find like anywhere you go. You can always find something. Why you just go and ask like, okay, where would you go, right? So I can tell you many places. It's there are so um, in near to like place like in Trivandrum there is Kovalam, right? There's a very famous beach.
Yes.
So and most people go there. But then there are also places like mountain areas where it's like a palm field. No one would go there, but it's a really nice place, right? In your 10 kilometers of drive we can do there, and hardly any person there. So there are those kind of places like throughout, like anywhere you go, you would find those. So you need to invest a little bit beyond the tourism advertisements, I think. Yes, it's exploring.
Okay. So the next question is little bit tricky, which is like if your life story is turned into a movie, then what would be the title?
I don't know, is that's a tough one. It's well, um, I think um, maybe something in the uh, explorer kind of,
Okay.
because that is something I would do from the very young stage onwards. Throughout life, I've been doing that. So I think like that could be the.
Okay. So do you have any lesson known fact about you, which probably will shock our audiences?
So I'm not. I don't read a lot of books. I play cricket and sports more. That's my. So it's uh, uh, probably like people will be surprised with that, like because you always relate like academic with like books and all those things, like but I tend to be much more of observer kind of, rather than like I would read a lot of novels but less of I read scientific papers but not really
Okay.
books per se.
Okay. Nice. Okay, so before we wrap up, my last question will be that what do you think about VLSI for all and the work that they are doing in this space?
Yeah, from what I know, that is interesting. That like you're able to bring in people and then popularize VLSI. I think that's very important. Given like India is putting so much of uh, emphasis these days on semiconductors and foundries coming up and things like this. There are a lot of things happening. So there is genuinely a lot of interest in the area, especially when you think like today computer science and other field like data science and other things have grown out of proportion, and most people are just going into that direction. uh, Given that situation, many of the core disciplines, the takers are very few, and people generally think going and studying electrical or electronics or mechanical may not really give you a chance. Uh, but it's far from the truth of the matter. If you look at a foundry today, you have huge power plants in it. You have chemical plant in it, like processing plants. So you need people with process engineering background. You need people with electrical engineering background, mechanical engineers. You need electronics people. You need material science. So every core area that we are talking about engineering is relevant when it comes to semiconductors. Software would be part of it. So and there is that as a core, and then you have a lot of allied fields, so allied disciplines. So if you want to build a product, then you need to worry about the finish of the product. Have a PCB, the PCB need to look perfect, good, right? So agronomics becomes kind of design becomes very important. The thought you need to put in from a customer point of view becomes very important. So all these allied fields also are very, very critical when it comes to product development. So that's why I think like promoting VLSI makes a lot of.
So before we wrap up, what do you think about VLSI for all and the kind of work that they are doing for the students?
I think it's very important that like we talk about VLSI in today's context, simply because in India, like there is a lot of emphasis on semiconductors that is put in. It's not just India, like around the world, like semiconductors have been like seen as something very important to do for self-sufficiency and things like this. And because many foundries are being set up, it also puts an emphasis on like multiple disciplines that are required to run a foundry. So if you look at a foundry today, like you would have a chemical engineer required for the plants. You would have like a electrical engineer required for the power station, power systems that are there. You need materials scientists who would be looking at various process engineering related things and so on and so forth. So the idea that like you'll only get a job in computer science and nothing else is being like addressed at the root cause of it. So semiconductors as such, like if you look at like that opens up that avenue, and talking about it can help uh, put a refocus or put an emphasis on all the other core disciplines that India is very well known for in the past. So I think in that way, like it's a very important thing.
Okay. So thank you so much for this insightful talk, and it was incredible talking to you. And I'm sure that our viewers has also gained a lot of knowledge as or I also have gained today. So thank you so much for joining in, sir. And for the viewers, thank you so much for tuning in and stay tuned for more such episodes. Thank you.